Today we are going to learn about 8th chapter in 11th standard mathematics, vectors. So first we'll see what is scalar. Quantity which has only magnitude is called scalar. Example, mass, area, volume. You know the difference between mass and weight. So mass value will not change in any place wherever it may be. Vector. Quantity which has both magnitude and direction is called vector. Example, velocity, acceleration, momentum, and so on. Velocity. 30 km per hour is the speed. 30 km per hour in the north is the velocity. So both magnitude and direction is called vector. A line segment. You have learnt in 6th standard. AB, both end points. This is a line segment. This is not a vector because AB has only length. Directed line segment. This arrow represents the direction from which to which it goes. A is a starting point called initial point. B is a final point. So suppose let us take a car moves from A to B. The distance travelled is AB. The direction is from A to B. So AB, this arrow represents vector. So AB vector, directed line segment, is called vector. A is the initial point, B is a terminal point. The direction is from A to B. This can also be represented in this form, small a vector. Vector can be even represented as small a vector. If its magnitude means magnitude of a vector, we can even say as modulus of a vector, length. Length of this line segment, magnitude of the vector a vector. We'll see some types of vectors. Co-initial vectors. From the name itself, it is clear. All the vectors having the same initial point, starting point. Like bus terminus. From Paris, the bus goes to Tambaram, Pundamalli, Chengalpet, in so many directions. So OA vector, OB vector, OC vector have same initial point O. So they are called co-initial vectors. Co-terminus vectors. From all direction the bus comes here. From Tirunelveli, from Bangalore, from Salem, the bus comes to Egmore. This is co-terminus, terminus, bus terminus. All comes to the same place. End point are same. Final points are same. So they are called co-terminus vectors. Collinear vectors, or it can also be called as parallel vectors. Vectors which lie on the same line or parallel lines are called collinear vectors or parallel vectors. I have drawn a line segment. I have taken 3 points A, B, C. This is AB vector, this is CB vector. They lie on the same line, okay, but direction is different. So, but they are called collinear vectors. AB vector, CB vector, or collinear vectors. PQ vector, they are parallel to AB vector. PQ vector is parallel to AB vector. In vector, they are also called collinear vectors. Yx vector. Y is the starting, x is the final. So Yx vector. It is parallel to CB vector. So all these vectors are called collinear vectors or parallel vectors. Scalar multiplication of a vector. Let us take AB vector. Can also be represented as small a vector. This length I have increases 3 times. So this A dash B dash vector is nothing but 3A vector. So A dash B dash vector is equal to 3 times AB vector. Or it can also be written as 3A vector. So 3A vector is parallel to A vector in the same direction. Here A vector and 3A vector 3 times, but the direction is different. So A vector, 3A vector are parallel. Parallel, another name is collinear, but in the opposite direction. So very important condition. If two vectors A vector and B vector are collinear or parallel, then one vector can be written as scalar times another vector. Either I can write A vector equal to lambda into B vector or B vector equal to K into A vector. Anything, both are allowed. Depending upon lambda, if lambda is positive, A vector, B vector have same direction. If lambda is negative, A vector, B vector have opposite direction. They are just direction or opposite to each other. Condition 2. A, B, C are 3 collinear points. In 6th standard you have learned collinear points mean they lie on the same line. Collinear points. AB vector can be written as lambda into AC vector. Or AB vector can be written as lambda into BC vector. Just now we saw the condition for collinear is one vector can be written as constant times another vector. So very important. To prove 3 points are collinear, it is enough to prove AB vector equal to lambda into BC vector or AC vector equal to lambda into AB vector or AB vector equal to lambda into AC vector. Anyone you will prove. Okay, then we say A, B, C are collinear points. Like vectors. Vectors which are in the same direction are said to be like vectors. Unlike vectors, just opposite. Vectors which are in the opposite direction are called unlike vectors. Localized vectors. Definition and theory is very important to the problems in vectors. So each and every definition what they are given, you have to know thoroughly. Localized vector. A vector which are drawn parallel to the given vector through the specified point in space is called a localized vector. A vector which are drawn parallel to the given vector. Vector is nothing but a directed line segment. Suppose I will take a table. Small box, I will keep it on the table. This is a vector, directed line segment. To parallel to this, I have written in another specified point, I have drawn a parallel line to this vector. So point of action is well defined. Suppose you push this small box from this line of action. What will happen? This is actually the middle. So it will come to this place somewhere here. How much force you are giving it. Suppose you push the same box from here. Okay. Surely you try at home. The small box will not move. It will fall down. So we know the action, what will happen in the end by drawing a parallel line in the specified point. Okay, so this is called localized vector. Most of the problems we did not use localized vector in our syllabus. We usually use free vectors. So what is free vectors? Vectors depend only on the length and the direction, and it is independent of its position in the space. I can switch the line anywhere, maintaining the same length, maintaining the same direction. So that is called a free vector. So in 11th standard syllabus, fully we are using free vector unless and otherwise they specify it. The free vectors can be taken anywhere in the space by choosing an arbitrary initial point. Okay, suppose for example, this is a line. This is A vector. This is B vector. B vector. Okay, this is so much length. What I'm going to do, I'm going to switch over this B vector somewhere, wherever I like, here. See, direction is maintained, length is maintained, but the position has been changed. Vectors depend only on the length and the direction independent of the position. First the place was here, now the place is here. Okay, then it is called free vectors. The free vectors can be taken anywhere in this space by choosing an arbitrary initial point. Okay, coplanar vectors. Vectors which lie on the same plane are called coplanar vectors. What are planes? Suppose this is a plane. So here so many line segments we can draw. That vectors are called coplanar vectors. Equal vectors. Two vectors are said to be equal if they have same length and same direction. Very important. Same length and same direction. AB and CD. Same length, same direction. Then they are called equal vectors. Zero vectors. Vector with zero magnitude and an arbitrary direction. Any direction it can have, but the magnitude is zero. Then it is called zero vector. Or another name for that is void vector. Void vector. Another definition for zero vector is the initial point and the terminal point has to be same. AA vector. So this is zero vector. Unit vector. A vector whose magnitude is 1 is called a unit vector. Suppose I have taken a vector A vector. 1 unit. It can be either centimeter or meter, whatever it may be. 1 unit, second unit, third unit, fourth unit, fifth unit, sixth unit. Like 6 centimeters in the scale. So A, this is 1 unit in the direction of A vector. So this is a unit vector. Same direction of A vector but magnitude is 1. So this is unit vector of A vector. It is denoted by A cap. So unit vector is denoted by a cap. So what is the meaning of A cap? Whose magnitude is 1 and whose direction is same as A vector. Okay. How many A caps are there in 1? This is 1 unit vector. This is 1 unit vector. So 6 unit vectors I have. So A vector equal to 6 unit vectors. 6 is nothing but modulus of A vector. So A cap is nothing but A vector. This is a constant, so I can divide A vector by modulus of A vector is A cap. So A cap formula we will be using in many places. A cap is nothing but A vector divided by modulus of A vector. Now we will see one problem in exercise 8.1. First problem in 11th standard volume 2. represent graphically the displacement of 45 centimeter 30 degree north of east. You have learnt map till 10th standard. This is north direction, this is south, this is east, and this is west. What they have given, north of east. For east, I have to take north direction. From east, I have to take north. North means go up. How much angle? 30 degree. Okay. So I am going to draw a line segment. That line segment is 45 centimeter. Or it can be kilometer or meter, whatever it may be. They have given 45 centimeter. So this is the vector. Vector, they have magnitude and direction. Direction is north of east. 80 kilometer 60 degrees south of west. North, south, east, west. This is west. This is west. For north means I have to go up. For south means I have to come down. So south, I have to come down. How much degree? 60 degree. What is this vector length? Magnitude 80 kilometer. Okay. So graphically we can represent the vector with the direction and magnitude. Next we are going to see addition of vectors. This is OA vector. This is AB vector. OA vector I am representing as A vector. AB vector I am representing as B vector. So in mathematics we have so many rules. Similarly, to add two vectors also we have a rule. So what is the rule? The terminal point of the first vector. This is my first vector, OA vector. The terminal point is A. The terminal point of the first vector is same as the initial point of the second vector. Second vector is this. Its initial point is A. So terminal point and initial point has to be same. Then only we can add. Okay. So A vector plus B vector I am going to add because terminal point of this and terminal point and initial point are same. I can add. Okay. Then what will be the answer? The answer is the initial point of the first vector, terminal point of the second vector. This is first vector. Its initial point O. And this is second vector. Its terminal point B. So see OB vector. So A vector plus B vector equal to OB vector. Or we can write as OA vector plus AB vector. Only this has to be same. Then only we can add. Equal to, answer is OB vector. This is called, since it looks like a triangle, this is called triangle law of addition. Which two vectors has to be added, we must know. What will be the result, we must know. See, these two must be same, then only we can add. Answer is this. Simple example we'll take. From Rayapuram, I am going to Paris Corner. From Paris Corner, I am going to Tambaram. So what I have started, my starting place is Rayapuram. My final place is Tambaram. So from Rayapuram I have started, I have went through so many places. That is not bother. What is the starting place? What is the ending place? Starting place is Rayapuram, ending place is Tambaram. Okay, so easy to remember. So this is called triangular law of addition. Complete a parallelogram with the help of the triangles. So OA, AB, OB. I am completing a parallelogram. So you know what is a parallelogram? Opposite sides are parallel and equal. So this is B vector, so this also B vector. This is A vector, so this is also A vector. See, OC vector is parallel to AB vector. So OC vector is B vector. CB vector is parallel to OA vector. So CB vector equal to A vector. Now OC plus CB. OC plus CB. Can we add? Yes, we can add because these two are same. We can add. What is the answer? OB vector. What is OB vector? Already I know by triangular law of addition is the A vector plus B vector. But OC vector is nothing but B vector. CB vector is nothing but A vector. So this side I got this one. This side I got. So B vector plus A vector equal to A vector plus B vector. You have learned this in 6th standard. That is commutative property. So addition of vectors satisfies commutative property. Okay. Negative of a vector. I have taken two directed line segments. Both are equal in length. Magnitudes are equal. But direction is different. This is from A to B. This is from B to A. Direction is different. So BA vector can be written as minus AB vector. Because their length magnitude equal, only direction is opposite. Different means you cannot have any direction. You cannot have like this and all. Opposite to this, opposite. From above means below, right means left. Okay, just opposite direction. Then BA vector is equal to minus AB vector. Very important for problem solving. Position vector of a point, very important. Of a point. Only for a particular point we can say position vector. Let A be any point in the space. OA vector is called position vector of a point A. OA vector is called position vector of a point A. Vector means directed line segment. They have given a point. I want a line. So I have taken one origin O. I have joined these two. This vector is called position vector. This O I can take anywhere. Okay, so this is position vector of point A. With reference to one point, I have found out the distance OA. So this is called OA vector. Position vector of point Q means OQ vector. Note, OA, triangular law of addition, OA vector plus AB vector equal to OB vector I know. AB vector means this I can take it to that side. So minus OA vector. Very, very important for problem solving. So AB vector is equal to position vector of B subtraction position vector of A. Okay. So suppose for one or two examples we'll see. What is PQ vector? Position vector of Q, second one, subtraction position vector of P. What is RS vector? Position vector of S subtraction position vector of R. Can we say this? CD vector, OD vector, subtraction OC vector. Now we'll do few problems in the exercise and example. Thank you.